So potentiometer, which is a potential divider, it is used. We can use the potentiometer as a variable resistance. It is used to find out the EMF of a cell and also to find out the internal resistance of a cell. Okay, generally potentiometer is a long wire. Generally it is of 10 meter long, that is 1000 centimeter. So you can get 10 meter long potentiometer wire, you can get 6 meter, you can get 4 meter, and even you can get 1 meter also. So if the wire is 10 meter long or 6 meter long, then the arrangement is made in such a way that wire we bend the wire at the end of each 100 centimeter. Okay, so here is a construction of 6 meter long potentiometer, that is 6 wire, 1 2 3 4 5 6. So 6 into 100, that is 600 centimeter, that is 6 meter. Okay, how the wires are connected, you can see the entire arrangement. Okay, so in circuit diagram we will simply use a straight wire. We shall use a straight wire. Okay, so basic principle of the potentiometer. Basic principle of the potentiometer is, if constant current flows through the potentiometer wire, if constant current flows through the potentiometer, this is the potentiometer wire AB. If constant current flows through the potentiometer wire, then the potential difference across any two points of the potentiometer wire is directly proportional to its length. Repeating again, if constant current flows through the potentiometer wire, then the potential difference across any 2 points of the potentiometer wire is directly proportional to the length of the 2 points, length of the wire between the 2 points. Okay, so now see, let I current is flowing through the wire. Let I current is flowing through the wire. This is the arrangement. This is a rheostat. This is an ammeter for measuring the current. Okay, whatever may be the voltage of the cell or the EMF of the cell. So suppose I current is flowing through the wire. Now if capital R is the resistance of the entire potentiometer wire, suppose the entire potentiometer has a length of L and rho is the resistance per unit length of the wire, then rho is the resistance per unit length of the potentiometer wire, then R equal to rho into L. Okay, and suppose small r is the resistance of the length AJ. Okay, so small r equal to rho into small r. Okay, is it clear? If constant current flows through the wire AJ, then what is the potential difference? V equal to I into smaller, I into smaller, that is equal to, you can get rho equal to capital R by L. So this is I equal to rho into L. Rho equal to capital R by L. So this is equal to I into L by L, IR into L by L. As you can see, R, the total resistance of the potentiometer, total resistance of the potentiometer wire is constant. L, the total length of the potentiometer, is again a constant. Now, if the current is constant, then V proportional to L. This was the basic principle of the potentiometer. Okay, this was the basic principle of the potentiometer. If constant current flows through the wire, then the potential difference across any 2 points of the potentiometer wire is is directly proportional to the length of the wire between the 2 points. Okay, so this was the principle. Now we shall use this principle to find out the EMF of a cell. So before starting this, you should know the difference between the EMF and terminal potential difference of a cell. Okay, we can use a voltmeter to find out the terminal potential difference, but we cannot find out the EMF of the cell by a voltmeter. So to find out the EMF, we have to use another device called potentiometer. Okay, so how we can use a potentiometer to measure the EMF? Here is the external circuit. Okay, and this is the cell having an internal resistance small r. Okay, and again this is the jockey J. This is the galvanometer G. Again we get the null point, suppose at a length L. Okay. So we have to determine the EMF of this cell, which has an internal resistance R. So now let two keys, this is K2 and K1. When K1 is closed and K2 is open, then no current flows through this external circuit. This is the potentiometer circuit and this is the external circuit. No current flows through this circuit. At the time, I was the current flowing through the potentiometer wire. Okay. Now we close both the keys K1 and K2. And we adjust the jockey sliding on the wire, potentiometer wire, and suppose we find out the null point at the point J. That means the galvanometer is now showing no deflection. The galvanometer is showing no deflection now. Okay, that means why the galvanometer is showing no deflection? It implies there is no current in this circuit. There is no current in the circuit. If there is no current in the circuit, then again I current, the entire current I is flowing in this potentiometer circuit. If there is a current in the circuit, then the current I may increase or decrease through this circuit. Okay, through the potentiometer circuit. If the current becomes 0 in the circuit, then as if it has no existence. Okay, so by adjusting the jockey, we get the null point at the point J. Now, why the current is 0? Why by adjusting jockey, why we get the null point? We get the null point because there is no potential difference between this point and this point, this point and this point. Okay? When the potential of these points become equal and these points become equal, then there will be no potential difference, so there will be no flow of current. Okay, that means when the potential difference across AJ, become equal to the potential difference of the cell, two terminals of the cell, that means the EMF of the cell, then there will be no current in the circuit. Listen again, when the potential difference across the length AJ become equal to the EMF of the cell, then no current will flow through the galvanometer. Okay, so at the balance condition, the EMF of the cell become equal to the potential difference across the length AJ. That means What is the potential difference across AJ? If I current flows through the circuit, then we have from our previous discussion that is it is equal to L by L into IR. L by L into IR. If this is the length, L is the balanced length of the potentiometer, and capital L is the total length of the potentiometer, and capital R is the resistance of the potentiometer. Okay. Then the EMF of the cell equal to L by L into IR. Now, in experiment you have to compare the EMF of two cells by using a known cell and known cell. That is, the known cell means you are given a cell with known EMF. Okay. So two cells are given, one is known and one is unknown. Now you have to compare their EMF by using the potentiometer, and thus you can determine the EMF of the unknown cell also. Suppose for the first cell, say E1, we have the null point at L1. So as evident from the above equation, E1 proportional to L1, and for another cell, say of EMF E2, we have the null point at L2. So E2 proportional to L2. Therefore, we have E1 by E2 equal to L1 by L2. Thus, we can compare the EMF of the two cells, and if one is known and one is unknown, then we can determine the EMF of the unknown cell. Okay.